Hello, welcome back. In this segment, I want to show you an application of SMT solver to program analysis, for example. Okay, let's consider this very simple function, foo, which takes long int type. In C, it usually means at least 64 bits, okay? That is the meaning of long type in the C language. So the program itself has, the function itself is really small, as you can see. I have a expression, which is a Boolean expression. As you can see, this is a Boolean expression, and this is a Boolean expression, and combined with a Boolean OR, therefore it's a Boolean expression. And the question is, what input T will hit us into the if part, and what input will take us to the else part? Okay, this is a very basic question we often ask during program analysis, security analysis, program understanding, whatever. So how do we automate this kind of analysis? Meaning, can I use the computer to find the value of T so that I know how to hit the if part, and also another value of T that will take me to the else part? Okay, so I wanted to show you how I encoded this using SMT solver Z3 and explain to you some interesting facts about this little program. Okay, if you wanted to try brute force, of course, you could do that. As I mentioned earlier, T is a long type, which means you will have to try 2 power 64 possible values, which will be a lot of values to try. How do we make it more efficient? So SMT solvers don't do brute force. They have more structured way of searching the state space. So let's use them to find out input values, if any, to hit this part, and set of input values to hit this part. Okay, that is the problem we are going to solve with the help of SMT solver. So all we have to do is remember this expression, right, and encode it into the Z3 solver, and we will use the Python API to solve it. So my first goal is to find an input value T that will take me to this part. Okay, let me show you that now very quickly. So I wrote this Z3 model, right, Z3 program. This is the expression we saw on the C code, right? And I encoded it as a 64-bit number because it's a long type, as I mentioned. Left expression is this T and this 7, bitwise and 7 not equal to 7, right? That's the left expression. The right expression is T left shift by 61 less than 0. So these are the two expressions, and they are connected by a Boolean OR. So that's the Boolean OR here. So we want the solver to come up with an input to make this statement to true. Okay, that means we can hit the if part of the expression. Let's ask the solver to do that for us. Okay, T equal to 0 solves the problem. We can quickly check it, right? If we send T to be 0, 0 and 7 will be 0, of course. So 0 not equal to 7 is true, so we don't have to worry about this part. So we will essentially get into this if T is 0. The thing becomes more interesting for the else part. Okay, the else part means the whole thing has to be false, right? So let me show you how I encoded the else part. So it's pretty much the same model, only one small tweak, right? Here we want the else part to be not of the expression, right? Only if the expression is false, we will go to the else part. That's the reason I added not. And I asked the solver whether you can find any T that will make the expression to be false. This whole expression has to be false for any T. Okay, so let's see whether we have any such T. No solution. The reason we get no solution is the solver was not able to come up with a T in 64-bit T which will satisfy this expression. Okay, which means that there is no way we can hit the else part of the program. So whatever value of T we put in, right, 0, 1, 2, whatever you put, you will never hit the else part. So that means there's something wrong in this little function. Okay, why would you have an if statement if something is always true, right? So there is something wrong in the logic. That's not what I'm going to talk about. What I wanted to show to you is that how you could use solvers to encode some very fine-grained expressions like this and try to solve it mechanically using Z3 solver.